Hey guys, so today we're going to talk about systems of equations. So I'm going to break this up into a few sections. First, we're going to look at what a system of equation looks like and how to graph them. The second one, we're going to solve by substitution, followed by elimination, and then we're going to do some application problems. So it'll probably be 4 videos. So what is a system of equations? Well, a system of equations is just 2 or more linear equations. Now we have types of solutions. We have 3 different possibilities here. We could have one solution. So if I have a system of linear equations, that's 2 or more lines. Let's just look at 2 for now. And they intersect somehow. Well, where they intersect is your solution. So whatever point this is right here, that's the solution to this system of linear equations. What is it? Couldn't tell you. But that's the answer, that little black dot. Now it's possible that we might have no solution. So let me that. So if we have no solution, then we'd have 2 lines that are parallel to each other. So if they're parallel to each other, they're never going to intersect, so there's no intersection point to be the solution. This is an example of that. Or we could have infinitely many solutions. So let's say we have a line like that, and then not only is the line parallel, but it actually is the same exact line. Boom. Then we have infinitely many solutions. So every coordinate that would satisfy one would satisfy the other, so there's just infinitely many possibilities. And that's how we're going to write it for this class. We're just going to say infinitely many solutions. Okay, so let's start by graphing. Graphing is definitely my least favorite way of solving these for a couple reasons. First, it's messy and it takes a long time. Second, it only works nicely if the graphs intersect at a nice point. But graphs aren't always going, or 2 linear equations won't always intersect at a nice point, so sometimes graphing is just not the way you want to go. So to do this, I'm going to color code my lines. This guy will be blue line, and this one will be red line. I'll start with red line. My y-intercept is 5. It's already in slope-intercept form for me. So that's my slope, my y-intercept. My slope is 1/6. So I can either go up 1 and right 6, or I could go down 1 and left 6. If I connect those dots with a line, that's my equation. Something like that. All right, now let's look at blue line. Y-intercept, -6. Slope, -5/3. So if it's negative, I can either go up and left or down to the right. Well, it's 5/3, and I don't have 5 spaces to go down. Excuse me. So I'm going to go ahead and go up. 3, 4, 5, and 1, 2, 3. Not touching yet, so I'm going to go again. 1, 2, 3, 4, 5. 1, 2, 3. There it is. And I'm just going to go ahead and go again so I can graph it more easily. Right there. Going to go ahead and connect the dots. And then what is my solution? Well, that's my solution. Well, what is that? That is a point. That is the order pair -6, 4. Done. Moving on. All right, this one, I want to look at this one because what is y equals 5? Well, that's a horizontal freaking line. It's got a slope of nothing because there's 0 x's, and it's got a y-intercept of 5, so you can graph it like that if you want to. Slope's nothing, so I go up nothing over however much you want to go. Doesn't matter. Y equals a number, horizontal line. X equals a number, vertical line. And there it is. All right, let's go ahead and look at red. Y equals 2x plus 7. That's in slope-intercept form. Y-intercept is 7, slope is 2, so I can either go up 2, right 1, because remember, 2 is the same thing as 2/1, or, which is what I need to do, go down 2 and left 1. And there we go, I found my answer. That's my solution where they cross. So I'm going to graph it. And right there, -1, 5. That's my solution set. Now, there are better methods for solving these than graphing, but you need practice graphing, so do it. Okay, let's look at this one. My second line, let's call you blue, is already in slope-intercept form, so we're good there. My first line, high red, is in standard form, so I could do a few things with this. First, if you're comfortable just rearranging the equation for y, do it, no problem at all. But if you want to memorize more stuff, you're welcome to. If we've got standard form, ax plus by equals c, then a few things are known right off the bat. X-intercept. To find the x-intercept, y is 0. So if it's ax plus nothing equals c, the x-intercept is just going to be c over a. And it is an ordered pair, so that y coordinate is 0 because we plugged in 0 for y. Y-intercept, on the other hand, probably can figure it out now. Plug in 0 for x. This is gone. I get by equals c. So it's c over b. Lastly, our slope. Now, if I were to rearrange this into slope-intercept form, I'd have to subtract ax from both sides. So that's going to be negative ax, and then divide by b. So negative a over b would be the coefficient of x, which is our slope in slope-intercept form. So these three things can be gotten directly from standard form. But if you don't want to memorize that, you can just rearrange the dang equation. Perfectly fine by me. All right, red, let's rearrange it. So that's a side note. If you want to do it that way, great. If you don't care, just do it. So I'm going to subtract 3x from both sides. So 6y equals negative 3x minus 12. Put your x's before your constants. Divide through by 6. And get some more room. Y equals negative 3 over 6. Use your calculator. That's negative a half. X minus 2. So there we go. Now it's in slope-intercept form. And we can confirm a few things. First, the slope should have been negative a over b. Well, negative 3 over 6 simplifies to negative a half. We're good there. Y-intercept should be c, negative 12 over b, 6. What's negative 12 over 6? Negative 2. We're good. So let me graph red here. Negative 2 is my y-intercept, and I had a slope of negative 1/2. So I'm going to go down 1, right 2. I'll do that a few times. I could have gone up 1 and left 2. I'll do that a few times. And keep going until I get here at the edge so I can easily just draw my line. You have to? Not at all. And something about like that'll work. Now let's look at blue. Y-intercept of negative 5. Slope of negative a half. That sounds familiar. Down 1, right 2. Down 1, right 2. Down 1, right 2. Or I could have gone up 1, left 2. What's going on here? I don't think these guys intersect. Why don't they intersect? Let me draw it. Nope, it doesn't look like these guys are ever going to intersect. Oh, let's look at the slopes. Negative a half. Negative a half. Same slope, they're parallel. Or the same line. In this case, they're parallel, so there is no solution. That's it. They don't intersect. No answer. Moving on. I believe this is the last graph we're going to do, if I recall correctly. So just use your graphing methods, however you want to do it. Don't care. Just get them graphed. but you do need to practice graphing. So first one's just about in slope-intercept form, so I'm just going to divide through by a negative. Call them blue. If I divide through by a negative, y equals positive x plus 6. Hey, slope-intercept form, done. Looking at red here. I need to divide through by 3. Well, I'm going to copy it down. 3x plus 18 equals 3y. Divide through by 3 to get rid of this coefficient of y here. Remember, slope-intercept form is y equals x plus 6, use a calculator, equals y. Not quite what we need to flip that around, so symmetric property of equality there. Y equals x plus 6. Now you may notice something. You may have the answer now, but if you don't, that's okay. We're going to graph them. So let's start with red. Y-intercept of 6, slope of, there's nothing on the x. Oh, that's an understood 1, that's right. So 1 over 1 if you need to. You can go up 1, right 1, or you go down 1, left 1. Up to you, doesn't matter. Actually, just wherever they makes the lines intersect. So if I graph red here, something about like that-ish. A little off, but yeah, close enough. Blue, y-intercept of 6. Oh, hey, is that my answer? Oh, let's see, my slope is, whoa, the same. So what is this? The same exact line. Let me actually fix this a little bit. So hold on. There we go. So I'm gonna connect the dots. And if I do that, oh my goodness, look at that. It's the same line. So what's my answer? Infinite solutions. In this class, we're not going to get any more specific than that. Infinite solutions, done. Move on. Now, this could be your answer over here, part of your answer, but not my class. Moving on. So I believe, yep, that was all of the graphing. So I'm going to stop this section and see you in a second.